Millennium problem number 2 is the Hodge Conjecture. Okay, I have a condition called synesthesia, I think it's called, which means I see things as colours. So the Hodge Conjecture has always been green for me. I don't know why. It's a green colour, but anyway, that's by the by. Okay, the Hodge Conjecture. Basically, someone called Hodge said he thinks that, or thought that, a certain type of visualisation of a certain type of equation is actually rational linear combinations of algebraic cycles which now are called Hodge cycles. So we use an algebra basically, which, as I've explained before, is like an efficiency method for symbolising a lot of symbols at once, basically. So rather than writing 10 million, you might write the letter E, for example, just for example. As long as you understand the code, you can know what's going on. Basically, what happened was, this is again the visualisation of mathematical equations through sort of like making a picture, really, I suppose. So basically, imagine you've got an extremely enormous amount of numbers in some investigation. We're talking proper hardcore mathematics here. Okay, so you've got loads and loads and loads of numbers, loads of formulas, loads of patterns potentially. You're looking through them, and mathematicians eventually started creating geometric objects from the results of their equations. So they're basically turning the numbers into a picture. Not so much a picture, more of a structure, really. Similar to children's building blocks, you know, the wooden blocks you get when you're a kid and you make towers out of them and bridges and things. Okay, so it's like that. So you've got a load of shapes, you start sticking them together, combining them. One type of shape with a certain form is the result of one equation, for example, just in general. Another shape might be added to that one, that's two investigations added together, and then you study the results of that equation. But rather than studying the actual mathematical, physical results, you study the abstract interpretation, which means you make the numbers into a building block shape, basically, and add the blocks together in your mind. And this is a way to look at the equations rather than study them, if you see what I'm saying. So you can see them rather than think about them in the same sense that you might do about mathematics or numbers in general. Okay. So basically, you've got an investigation, extremely complicated, make it into a shape, add that shape to another investigation that's extremely complicated, another shape. Okay, times this by, I don't know, a lot anyway. And basically, what happened was, originally, they were always able to be interpreted geometrically, so we could always understand the shapes that we were dealing with, basically. In essence, that's what it means. And over time, this gave mathematicians really powerful tools to study their investigations, the results of their investigations, more importantly. But unfortunately, this geometric interpretation became obscure because the numbers symbolised by the building blocks became so enormous. So we had so many building blocks stuck together in different ways that they were able to stick them together without understanding the mathematics that was behind them still, because they were dealing with them on a higher level. In the same way that I could build a house out of bricks without understanding what each brick is made of, the constituent parts of each brick, the process of using a kiln and things. Okay, this is translated into mathematics. So basically, it meant that they didn't have to study every single number that made up every single building block, essentially. So they got lost, basically. This is the way I see it anyway. So you've got a massive, massive mathematical structure that can be interpreted as geometric, or could originally be interpreted as geometric, but now it's come so far that the geometric interpretation has been lost, basically. In some places, in some investigations, it was necessary to add pieces that might have seemed geometric, but no one was actually sure whether they were geometric or not, or able to be seen as a shape or not, if you see what I mean. Whether they fitted in or not, whether they were true to the original concept of the building block, or whether they were a different type of block. And that's what happened. And then Hodge came along, as I said before, and said that for certain particular types of spaces, or types of building block, if you like, some pieces are actually rational linear combinations of pieces called Hodge cycles. So basically, Hodge was saying, even though these objects, or the results of these blocks, the structure that we've built out of these blocks, mathematically speaking, is extremely complicated and almost impossible, pretty much impossible. This is actually seen to be the most difficult Millennium problem to answer out of the whole lot. Even though they seem not to be able to be interpreted geometrically, Hodge said that he thinks that certain types can be, but nobody's been able to prove whether they can or not. And that's the basic simplicity with it, really. That's the simple core of this problem. It comes down to an opposite. Was Hodge correct, incorrect, or not? Which one? As with all the rest of the Millennium problems, it comes down to an opposite answer, as I've just said. Extremely simple. Are these pieces rational linear combinations of pieces called Hodge cycles, the bits that didn't seem to have a geometric interpretation, or not? Okay? Now, if you look at a shape, any kind of shape, whether it's represented by the mathematical equations or anything else, it's either a curve, a straight line, or a combination of the two. Okay? Am I wrong? Am I right? Am I neutral? What do you think? Okay? I'm wrong, right, and neutral simultaneously in pure theory and pure thought. Okay? There is the possibility for me to be able to say this, or I wouldn't be able to say it on camera, would I? The answer is I would, and I wouldn't, plus neutral. Ridiculous and stupid as this may seem, this is the literal truth when you get into the theory of everything. Okay? So basically, like I say, they're asking for an opposite answer. They're asking for one singular answer out of a possible three. And I'm giving three answers, not just one. If anybody proves the Hodge conjecture, inverted commas, with a proof, that still means I can say, what about the opposite to that, plus neutral? And like I say, if you want to look at shapes, a straight line, a curve, or a combination of the two, that accounts for the negative, positive, and neutral potentials within everything, including shapes, surprise, surprise, including numbers. Numbers are symbolised by 1, singular, the opposite to 1, non-singular, or neutral, which means 0, not 1, not more than 1, okay? The opposite to 1, that would be, okay? So, and that's the answer to the Hodge conjecture. There's three possible potentials, okay? It's because everything has three potentials. It's simple as that. That's why I've got a left hand, a right hand, and a centre line down my body. The same works for every single thing in the universe, all mathematics, all equations. It makes no difference really. You can use this idea to explain, answer, and understand anything and everything in the whole universe, including, but not limited to, the Millennium problems offered on the Quaker Mathematics Institute website, okay? And that's the Hodge conjecture basically summed up. Hodge asked a question singularly saying, I think these pieces are made in a certain form, and nobody's been able to say yes they are or no they're not. And even if they did say yes they are, I'd just say, well, according to my theory they are, they're not, plus neutral. As I say, this seems ridiculous, but that's by the by. I mean, how, I suppose really, how sensical in a singular sense did you expect a theory of everything to really be, I suppose. I mean, obviously I missed out a lot of details here, but I think details just confuse things really. That my idea is simple, and I think the only reason that we seem off track in certain types of these problems and is because we're considering the details too much, you see, I think, and I think that obscures the simplicity and the simple principle behind the universe, which is three potentials simultaneously. And this is just my newest, should I say, video about the Hodge conjecture. Okay.